So, test tomorrow, 2 topics, implicit and related rates, although never pass up an opportunity for a Venn diagram. Related rates is more like a subset of implicit differentiation. So, that's what's on the test. There's your test outline, by the way. Sorry, that's not much, but implicit differentiation is what all of it is, and then specifically some word problems that we call related rates. So that's a good way to think about the stuff that we've learned. Now, we don't need to do anything new today, like no presenting new material, because we've seen all of this. But we definitely want to answer some related rates questions from the book. Here's today's assignment book questions, and then finish, maybe the notes. I'm not sure we'll finish. We'll get through some of them, and then today's assignment is a worksheet on related rates, the odds, and then due Tuesday. Let's see, what have we done since the last? I guess we could count worksheet 4. That was the one that was from pictures or from graphs and tables. It's not really on this, but it was done after the last test, so we'll count it as one. Then we did page 146. We had a worksheet on implicit. Then we did page 153. Today we'll have a worksheet on related rates. And you also have a review. 3, 4, 5, 6. You know what? Let's do it this way. Let's not include worksheet 4, because that's not really what's tested. So I don't want you counting that as one of them. And let's say that 4 of the 5 are due. So you pick the 4, which may mean you pass on the review, or maybe you did the review and you feel good about it and you don't want to mess with today's assignment. So if you've done everything I've given you, you'd have 4 of the 5 done. Now, that's probably not very many of you, but that could be a few of you in that position. And again, today I'll just assign the odds on that related rates worksheet. So, sort of super big picture overview. What's on the test, plan for today, book questions, finish notes, get started on that worksheet, although we won't get started on the worksheet, and then the 5 things we've done, 4 of which are due tomorrow. That's the plan. Questions from the bookwork, 150, whatever it was. 153. Nikita, you had questions?
17, 21, C, and 25. You just do all of 21 and 25. Yeah,
Sure. Yeah, good plan. Oh, by the way, I don't know if you guys use Schoology very much. Some of you do, some of you don't. On this implicit worksheet, I did the thing where I ended up working different problems for each class. And so Schoology videos they don't have all of them, but they have like half of that worksheet worked out. So we did a few in class, and we did a few in 5th and a few in 6th, but there was a different few, and I recorded all of them and put them up there. So if you need help on that one, then go check out Schoology, and there are more videos available. And I hope to do the same thing with page 153. We'll see what questions the other classes ask. But I try to keep track of it, and if they ask different questions, record those and post those. All right, 17. Yeah, goodness, we hadn't done one quite like that. So good question. There's one on the test, very similar to 17. So star, highlight, whatever you need to do. 17 is a good one. At a sand and gravel plant, sand is falling off a conveyor onto a conical pile. So we got sand and it falls off the conveyor belt onto a conical pile. Okay, so it lands and it falls and it sort of naturally makes a cone. Hope you enjoy my artwork. At a rate of 10 cubic feet per minute. By the way, if we're thinking of steps, again, you don't have to think of steps, but it may help. Step 1 was draw a picture, so we kind of have that. Step 2 was translate, and so I'm kind of in the process of translating English into math. The diameter of the base of the cone is approximately 3 times the altitude. Diameter is 3 times. Altitude would just be a fancy word for height. So I'm going to say diameter is 3 times the height. And I think that is a constant ratio, I guess. So as more and more sand gets poured on, the pile gets bigger, but the diameter is always going to be 3 times the height. At what rate is the height of the pile changing when the pile is 15 feet high? Hint, how they give you the formula for volume. All right, let's back up and start translating here. So what is 10 feet cubed per minute? What is that in terms of variables? dV dt. At what rate is the height of the pile changing? So what's it asking us to find? The rate the height of the pile is changing. But what is that in terms of our variables? dH dt. Good. Find dH dt when h is 15. Find a formula? Well, it gives us a formula, so that was kind of nice. Now, here is where this problem is different than the ones we've done before, so I'm glad you asked it because it's different. I hadn't done one quite like it, and it's on the test. So all those are great reasons to ask this question. There was a step in the directions on our notes about finding an equation that makes this equation a little bit simpler. Right now, if we take this derivative, what rule would we have to use? Product rule, chain rule, and product rule. And so if we take a derivative now, I'm not going to do it. I just know it'll have something with dr dt and then something with dH dt. Right? Does that make sense? That's very rough product rule. Like I know that's where we're going to land without actually doing it. And we don't have any information about dr dt. So I'd really rather not have r in my problem. Like dH dt, that's what we're looking for. We know dV dt. We can figure out everything else, but we don't know anything about dr dt. So it would be nice if r went away somehow. Well, this was extra sneaky. If the diameter is 3 times h,
Are we not going to find it? Because if we know the diameter, is 3 times h, can we just divide by 2?
sure. So the radius is 3/2 h. Okay with that? We divide both sides by 2. It's a little bit weird because you divide both sides by 2 and then poof, it became r because d over 2 is r. So one thing we could do, this would be the long way around, is to differentiate this, and then we would know dr dt in terms of dH dt. I don't want to do that though. I'd rather just, in place of r, let's put that. So for this particular pile of sand, that's our formula. In place of r, I put 3/2 h. Now I need to clean that up a little bit. 1/3 pi 9/4 h cubed. And then one more cleanup. 9/3 will reduce, so 3 pi over 4 h cubed. Okay with that so far? We still haven't really done any calculus. I mean, I guess the translating was calculus, but then all of this equation stuff is algebra. Now let's take a derivative. We won't have to worry about the product rule, and dr dt won't show up because r is not even in there. So let's take this derivative. dv dt equals 3 pi over 4 times 3h squared, h squared. And that's the mistake some people are going to make. What am I missing? dh dt. And let's see, now let's revisit this thing. Find dh dt. So we're looking for this when h is 15. So we know h. And they told us what dv dt is. So we've got everything we need to find dh dt.
Where did you get the cube on h?
Because this was r, 3/2 h squared.
Oh, I didn't see the h.
Yeah, my h was kind of hiding in there. So dv dt is 10. I sense a safe stop in our near future here. 9 pi over 4, 15 squared, dh dt. So let's see, how much can we do at once here?
Wait, what is it, 9 times 4?
I combine the 3's.
Oh,
So I'm going to multiply by 4 over 9 pi. All right, the rest of this problem is algebra, but that doesn't necessarily mean it's easy. So 10 times 4 over 9 pi. And then I'll divide by 15 squared. And there's my answer. I could type that in and get a decimal, but I don't want to mess with it really. I do need to include units. One way to include units, of course, is to keep up with all the units during the whole problem and then do the unit algebra and see what you're left with. The other way to do units is to look at dh dt and know that units should be what? What's h measured in this problem? Feet, and time is measured in minutes. That's how we usually do units. I mean, probably the more official way is to keep up with all the units and make sure we get feet per minute, but this would have been really ugly to carry all those units in there when they're cubed and dividing and canceling out. So most people just tag them on at the end based on what we know we're looking for. So that was a great question. The main thing about that one was this extra step in there where it told us how height and radius were related so that we did not have to use the product rule. We were able to come up with sort of a special equation just for this pile of sand and make our life a little easier. Good one. I am glad you asked that one. I just looked at the test before first period started to see basically is there anything I need to make sure I say today to hints or whatever, and this was one of them. And there's one other, but I'll make sure we do that one as well. 21 and 25 are your other asks. The moving ladder. Oh, perfect. This is the other one I wanted to talk at. You guys are on top of things. A ladder 25 feet long is leaning against the wall of a house. See figure. So you got to kind of look around and find the figure. I don't know if the figure's that helpful because, hey, look, it's the ladder against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. So something down there is 2 feet per second. By the way, we've sort of merged step 1 and step 2 in this problem, where step 1 is draw the picture, step 2 is translate. Kind of doing that all at once here. Part A, how fast is the top of the ladder moving down the wall when the base is 7, 15, and 24 feet from the wall? Oh, I don't like question A because it's really 3 questions in one, right? So it's not really A, B, and C. It's like A1, A2, A3, and then B and C. Let's do one of the A's, and then we'll do B and C. Because if you can do one of the A's, you just plug in different numbers for the other two. Okay, how fast is the top of the ladder moving down the wall? So that's what we're looking for, but we need some variables here so we can call this thing something. Obviously, Pythagorean theorem, a squared plus b squared equals c squared. Nikita, you asked, just so my work matches yours, did you label one of these A versus B?
I labeled like the base A and then the other one B.
Okay. It completely doesn't matter which one you label what, but she asked the question, so I wanted my work to match her work, so we'll go with A and B. So that means, what's 2 feet per second now in terms of our variables? The ADT. And we're trying to find the BDT when its base is 7 feet from the wall. So when A equals 7. And then also 15 and 24, but we'll just do 7. A squared plus B squared equals C squared. So I know A. I know A. I can know B. I know C. The ADT, the BDT is what we're looking for. What's dCdt going to be? Why 0? Because it's constant. So some people will figure that out right here and put a constant in for C, and that way they don't have to take its derivative. Yeah, let's do that. We didn't do it that way last week. We took a derivative and then filled in 0. But if we see that ahead of time, we can make that adjustment and makes the derivative a little bit easier. So 2a dAdt plus 2b dB dt equals, well, the way we did it, it equals 0 right away. If you don't make that change, you get 2c dc dt, but dc dt is 0. So one way or another, you end up with 0 on that side. All right, find dB dt. So there's what we're looking for. When A is 7, got that. They told us what dA dt is. That's 2. We don't know B. We don't explicitly know B yet, but I can find B doing a squared plus b squared equals c squared. Or, if somebody remembers this particular Pythagorean triple, it's 24. If you don't remember it, that's fine. You just punch it in the calculator. It takes you 10 seconds more. 7, 24, 25. Ask me that again in a minute. Let me check on that. Because, yes, you would really like that for this problem, wouldn't you? So now I know everybody. Let's see. I can plug in first, or I can do algebra first. Doesn't matter. Do you have a preference? Plug in. Are you okay if I divide by 2s, or we leave the 2s? Okay, we'll leave the 2s and plug in first. So A is 7, the ADT is 2. 2 times B, we just said, is 24. The BDT is what we're looking for. All that equals 0. And now the only thing left is algebra. But that's not a safe stop because I haven't solved for dB dt yet. I haven't answered the question. So I'm going to subtract over 2 times 7 times 2, and then divide by 2 times 24. Yes, no, you okay? Okay. I don't have a calculator, so why would I multiply it out? No, I mean, you're right. Like, I could multiply it out. They're legit numbers. It would be easy to do, but this would be a safe stop. And again, we don't really keep up with the units. We just grab them at the end. B is measured in feet. Time is measured in seconds. So make sure you put the units on, but you can wait till the end to do that. And then, yes, if we wanted to simplify, 2's would cancel. 2 and 24 would reduce. So negative 7/12 feet per second. For this particular problem, does it make sense that dB dt is negative? Yeah, it's moving down. So like if B is the length of this piece, that piece is getting shorter. So yeah, it makes sense that it's negative. I have no idea if it makes sense that it's 7/12, so that would require more understanding than I have. But I at least feel good that it's negative. Part B. Consider the triangle formed by the base of the house. Well, I assume that's the triangle there. The base of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall. Find the ADT. Uh-oh, this is going to be tricky because we have lowercase a's and uppercase a's, but when lowercase a is 7. And the ADT lowercase a is still 2 feet per second. So what's the formula for the area of a triangle? They were nice to us here. We have a right triangle. 1/2 base times height. So 1/2 A times B. So in number 17, A and B, like we were able to get rid of one of the variables. Here, A and B, I mean, they're related to each other, but I don't think I can substitute for one of them. I think I'm stuck with A and B. So I'm going to have to use the product rule. And I can either leave the 1/2 out front of everybody, or I can attach to the 1/2 to the A. It's not going to matter. I'm going to have 1/2 on everything anyway. I'm going to leave it out front and kind of do it this way. Can I chain rule, or can I product rule in place on this one, or do you want me to show the steps? Steps always, and that is completely okay. F prime is the ADT, G prime is dB dt, but this one wouldn't be terrible in terms of chain ruling or product rule in place. You could probably figure it out. So first one times derivative of the second one plus second one times derivative of the first one. And let's see what we know here. A we know. dB dt we found from the last. That's why they ask us that first. So we know A, we know dB dt, we know B, we know dA dt. We know everything we need to know. So 1/2. A is 7.
Wait.
Yep.
There was more than one things for the first, and then just A1 whatever. Like there were more than one answer.
Yes, but the one that we happen to pick, the right one, when A is 7, that's the one we did. So you're right, we need to be careful. But when A is 7, dB dt is what we found in part A. And thankfully, the first question from part B was A is 7. So you're right to be super careful because dB dt isn't always this. dB dt is changing, but we found it when we needed it. And that is a safe stop that I do not want to mess with. Except I still need units on there, feet squared per minute. Area, feet squared, time in minutes. That one you could do the units without too much difficulty. Feet times feet per minute. Connor? Oh, am I in seconds rather than minutes? I sure am. Seconds. That's one of those errors that's so small I might not even take off a point. It's like you remember to do units, you copied the wrong one down.
So if it was like area problems, you have to square the unit.
Right.
Okay.
Feet squared, inches squared, centimeters squared, something squared. All right, part C gets a big red circle around it. Why do you think that is? Yes, there's one sort of like it on the test. Find the rate at which the angle between the ladder and the wall of the house. Let's make sure we grab the right, not the right angle, the correct angle. The ladder and the wall of the house. So this angle is changing. So find d theta dt. When the base of the ladder is 7 feet from the wall. Okay, good. So when A equals 7. That's good, because when A is 7, we know lots of stuff right now. We know area, we know dA dt, we know dB dt, we know A, we know B. Like we've got this problem pretty well mapped out for when A is 7. Now I need an equation that has theta in it, and preferably A and B in it, since I know stuff about A and B as well. So is there an equation you know that relates theta, A, and B? There is, but you don't remember it.
Opposite over adjacent.
Yeah, that's opposite and adjacent. So what trig ratio talks about opposite and adjacent? Tangent. So tangent of theta is opposite over adjacent. A over B. And if we take the derivative, d theta dt will show up for us. Because the derivative of tangent is secant squared, chain rule, times d theta dt equals what's required on the other side? The quotient rule. I guess it's not awful because they're just, the derivatives are easy. Putting together the quotient rule isn't particularly fun, but the individual derivatives weren't hard, at least. So let's see, fg prime a dB dt minus gf prime b dA dt all over g squared.
I thought the GF prime was first.
Did I mess that up? I sure did. Now I'm trying to think of a way to fix it without erasing it. Would it bother you if I just put the minus sign and made this one plus? I mean, it's mathematically accurate. It doesn't feel right, but now the GF prime is positive. So thank you. I did make a mistake on that. And I'm trying to find d theta dt. Here we go. I'll rewrite it this way. So fg prime minus gf prime. No. Can't write and talk at the same time. GF prime minus FG prime all over G squared. When I divide both sides by secant squared, I get secant squared in the denominator. What's that the same thing as? Make my life easier here. Cosine. Now, this is going to be another glorious safe stop situation. Because I know I don't know cosine of theta yet. Cosine of theta is adjacent over hypotenuse. 7, 24, 25. So the cosine of that angle is adjacent over hypotenuse, 24 over 25. Alright, let's see if I can fill in everything correctly here. For the calculator, I could get an answer. How about units? Or let me slow down. You okay with all those? All I did was plug in all the pieces very carefully. Couldn't have said 4 different things to plug in. 5 different things. A, B, both their derivatives, and cosine of an angle. Back to units. What's theta measured in? Okay, I'm glad you said that even though it's wrong. In calculus, we're always going to be in radians. We'll always be in radians. You don't have to worry about degrees in here. We'll always be radians. And again, get a calculator if you want to figure out what that number is. A little bit of just kind of checking. Is this answer going to be negative or positive, or can you tell? Well, I got negative here, so definitely going to be positive. Does it make sense from my picture that my angle is getting bigger? Exactly. You're like, yeah, because it's doing the thing, you know? A second later, it looks like this, and that angle is bigger. So again, the positives and negatives you can kind of check whether they make sense. And I have no idea what that answer is. It's definitely positive, and that makes sense with the problem. Which is why I should check that, because when I messed up the GF prime, FG prime, if someone had not caught that mistake, then this would be negative. And hopefully I would do that check, and I'd think, wait a minute, this is not supposed to be negative, and maybe I could go find my mistake. Good questions. Number 25. Air traffic controller spots 2 planes at the same altitude converging on a point. And by the way, there is a picture for this, so if the words don't really make sense, the picture there hopefully helps. This looks like it might be another a squared plus b squared equals c squared thing. As they fly at right angles to each other, see the figure. One plane is 225 miles from the point, moving at 450 miles an hour. The other plane is 300 miles from the point, moving at 600 miles per hour. At what rate is the distance between the planes decreasing? So there's the distance. And yes, if they're both flying toward this point, then the distance between them is getting smaller. Kind of a situation on our hands here. So what formula could we use that would relate what's going on here? Okay, x squared plus y squared equals d squared. I'll call that x and that y. And unlike that last problem we did, where, well, what made the last problem nice that doesn't happen in this problem? Okay, yeah, more than we knew what it was. I mean, that was nice, but it was a constant. Here, it's changing. So all of these derivatives are going to be involved because they're all changing. X is changing, y is changing, d is changing. So nobody's constant in this one. We're stuck with all of these derivatives. Let's see, and we're searching for d dt, which means we have to know everybody else. X is 225. That's an easy one. What's dx dt? Good. Negative 450. What's dy dt? Negative 600. So that's important on those. They're negative because that distance is decreasing. Even before we work this problem, do we think d dt is going to be positive or negative? And it's negative because a second later it's smaller than it was before. So I think we know it. Oh, we don't know d. 300 squared plus 225 squared. Maybe that's a special right triangle, but it's so big I don't know what it is. It is. D is 375. I'm going to do the algebra first this time, although there's not much of it. X dx dt plus y dy dt, all divided by d. So I divided by 2. Well, I guess I divided by 2 and d, but all the 2's went away. So now it's just carefully putting things in the right spot. X is 225. Dx dt is negative 450. Y is 300. Dy dt is negative 600. And d was 375. And safe stop that if you like. That's definitely going to be negative though. So they're getting closer to each other at 720 miles per hour. I hope they're not on a collision course because not good. How much time does the air traffic controller have to get one of the planes on a different path? Well, that would just be distance equals rate times time. And I guess you could do that for any of the, you could do that for x, for y, or for d. I'll do it for d. So the initial distance is 375. The rate is 720. So 375 divided by 720. Yeah, sorry. So 0.521 hours. So it's not, 0.5 sounds like not much time, but we're in hours, so half an hour. So urgent, but not deadly yet. He has time to make a correction.